So we've got a quick 3 relating to ionic bonding. See what we know. Here are the 3 questions. Change a magnesium atom into an ion and show the charge on that ion. We've got change a chlorine atom into an ion and also show the charge on that ion. And then draw the ionic structure of a compound that forms between the magnesium atom and a chlorine atom. Give yourself about 5 to 6 minutes to do those questions. That's a 1 mark question here, usually another mark, and this one will be worth about 2 marks. So in reality, give yourself about 4 minutes. Okay, so stop, pause this video, have a go at them. Here are the answers coming now. Okay, so question 1, let's have a look. To change the magnesium ion, I'm going to show you bits and pieces of what I'm doing. So firstly, I'll show you the shorthand version. So the magnesium atom will go and form, because of loss of 2 electrons, it'll form a magnesium ion of 2+ charge. Showing the shells a little bit longer here. So I'll just draw that underneath here. Magnesium. So I'll do a little bit shortened here. So we've got 2, 8, 2, and we go and form a magnesium ion here. Magnesium 2, 8, and just drawing in a different color. Let's say green. Remember here the charge for an atom. So remember this is an Mg atom, and this forms an M magnesium ion. So doing the charges here, remember that's 12 plus for the protons, and that's minus 12 for the electrons. Overall charge is 0. Over here, we've still got 12 protons, because remember, the protons aren't lost when we form ions, it's electrons. So we've lost 2 electrons, so 2 plus 8 is 10. So 12 take away 10 is plus 2. Hence that charge here. Next question, change a chlorine atom into an ion and show the charge of that. So in the previous one, this was a metal, and they have a tendency to lose their out-of-bounds electron. This is a non-metal, so you need to distinguish between the two, and they tend to gain electrons in the outer shell to reach what we call a stable electronic configuration in noble gas. So chlorine shorthand here as an atom goes to form the chloride ion. I'm going to put a 1 minus charge there. So this is an atom. This is an ion. As a shells, I'll show you here. So we've got chlorine. First shell has 2, second shell has 8, third shell has 7, and then it goes to form a chloride ion. How does it do this? I'm just going to put it in a different color. Remember, it gains an electron, 1 electron, and we get the full outer shell here. 2, 8, and then we complete the shell because we've gained 1. Now, in terms of charge, we've got here 17 plus minus 17. The overall charge is 0 for all atoms in neutral. And now that we've formed a chloride ion, remember the name change, chloride ion. I'll just highlight that there, chloride ion. We've got 17 protons. Now we've got, because we've gained 1 electron, 2 plus 8 gives us 18. Adding that together, we get minus 1, hence the charge here of 1 minus. Let's have a look at the next question. So third final answer for quick 3 on ionic bonding. We're looking at an example. Draw the ionic structure, compound that forms between the magnesium atom and the chlorine atom. In shorthand terms, I'm just going to write the magnesium atom here, plus the chlorine atom here. Remember, the magnesium atom's a metal, the chlorine atom's a non-metal. Hence, you'll have a propensity to form a ionic compound. With the charges, this forms 2 plus, that forms 1 minus. To balance them off, we have to have 2 chloride ions, 2 plus, 1 minus, to balance off the charges, and that forms that sort of electrostatic bond between the positively charged ion magnesium and 2 lots of chloride ions. Now showing you in electron shells, magnesium 2, 8 in a second shell, 2 in a third. We add that to chlorine, 2 in the first, 8 in the second, 7 in the third. Now what happens here? This loses, magnesium loses 2 electrons. But you know that they'll go here, so that'll be plus 1 electron. There'll be another chloride ion hanging about that it can give the other electron. Remember, we're not just looking at one of each, there's a lot of them. And then we get the second electron here, plus 1 electron being deposited here. So the magnesium loses 2 electrons, and the non-metals gain 1 electron each. Okay, in terms of a diagram, they look something like this. Magnesium, we've got 2, 8, and it's a 2 plus charge. And I'll draw chlorine green. Chlorine, and I'll put it the other way around. As soon as I hit the erase button, so I'll do it the other way around. Chlorine has got 2, 8, and then 8, and there'll be 2 of these. So I'm just going to put little brackets, say 2 of them, and that's a 1 minus charge here, and your magnesium's 2, hence the correct formula as shown here. In terms of a formula, MgCl2 would be your lowest ratio formula that would be formed and stable.